Hi guys, if you're watching this video, what this is for is I'm going to walk you through all 15 problems, just at least the setup. We're not going to solve them all the way through, but this video is for you if you are stumped on a particular problem or if you just are really struggling with this. What we're going to do is we're going to talk through the setup of the various problems. So here we go. So we have three basic exponential equations that we have studied, and the first one is just your general y equals a b to the cx. And in this equation, a is your initial amount, b is your growth or decay constant, and then c is the number of times it's growing or decaying per unit of time. And so that'll be different based on the problem. And this one, you're going to use if it's just any exponential situation that's not involving money. So for the money ones, for the compounding interest, that's when we're going to use our two other equations. So the next equation is the amount in an account at any time t is equal to the principal invested times 1 plus r over n all to the nt. And this one, you are going to use, and keep in mind, R is a interest rate as a decimal, N is the number of times it's compounded per year, and then T is the amount of time in years that it's left in the account. Go back and look in your notes if you need more help on that one. But you are going to use this whenever the problem talks about money that is compounding a certain number of times per year. It might say compounding annually or compounding semi-annually or compounding quarterly or monthly or daily. That's when, so I'm just going to say compounding blank times per year. That's when we're going to use this equation. And then the third one is the famous PERT, P e to the RT. So you got to remember, E is a constant. And this equation you are going to use whenever it has a certain word. And that word is continuously. Whenever the problem says you are compounding continuously. So what you're going to do is you're going to first pick which formula you're going to use for all these problems, and then go through the problem. You're going to be solving for different variables. You're not always going to be solving for like a y. Sometimes you're going to be solving for something up in the exponent. Sometimes you're going to be solving for the initial amount. You're going to be solving for various things. So let's set up number two. Number two. How much money do you need to invest at 2 3/4% in order to have $12,000 after 7 years? So right away, think about which equation are you going to be using. Think about it. Try to fill it in. Notice it's money, and notice it says it is you're just investing it at 2 3/4%. So in this equation, it doesn't specifically say how many times it's compounding per year. That's a little bit confusing. And because of that, we are going to assume that it is compounding annually. Compounding annually. Oh, how do you spell annually? We'll go with that. Okay, so what you're going to be doing is we're going to be doing our A equals P times 1 plus R over N, all raised to the NT. Now go ahead and fill in your variables. Fill in your variables. So let's see, 2 3/4%. You got, so that's 2.75%. Make that into a decimal. That's super important. So let's see, it's 0.0275. And what's that going to be? If you are thinking that's the R, you are correct. That's the R. Okay, now we want to have $12,000. That's like going to be the total amount in the account. So what's that one going to be? If you are thinking that that is the A, you are correct. Okay, 7 years, that is going to be your T. And then compounding annually, that's what we're assuming it's doing. That means that your N is going to be N equals 1. So now just go through your equation and fill stuff in. You've got $12,000 is going to be equal to, we don't know our P. And actually, when it says how much money do you need to invest, that would mean this is the P. P is what I'm solving for. That's what I'm solving for. Okay, so P I'm just going to leave as a P. I've got 1 plus my R is 0.0275 over n, which is 1, all raised to the nt, so 1 times 7. All right, now you just got to solve the equation. You got to solve the equation for p. So hint, hint on this one, this is multiplying. So in order to get your p alone, you need to do the opposite. You need to divide everything by all of this. All right, you guys can do that. Let's look at the setup for number 3. Number 3, how much money will you have in 6 months? When you see that right away, it's money. So I'm either going to be using the PERT equation or I'm going to be using the A equals P times 1 plus R over N to the NT. And when it says how much money will you have, well, check it out. That would mean that is going to be your principal. We know our principal. That's going to be your total amount. Total amount. Which means I'm going to be solving for A. I'm going to be solving for A. So it says if you invest $1,000. So that would mean the $1,000, that's your principal. That's how much I'm investing. 3%. Okay, what's your R? If you're saying it's 3, you are wrong. It is not 3. It is 0.3? No, 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 no. 0.03. That's your R. That's your R. It's compounded monthly. So compounded monthly means that my N is 12. So let's see, we've almost got everything. What's the last thing? Let's just write out the formula. A equals P 1 plus R over N to the NT. Now, why am I not using PERT here? If you're thinking because it's not saying compounded continuously, you are correct. So let's see, we've got our P, which is 1,000. I'll fill that in. I've got 1 plus 0.03 over 12, all raised to the N times T. So I know my N is 12. What's my T? Going back to the problem, 6 months. But here's the trick. In this formula, we know that this is time in years. This is time in years. It's not time in months. It's always time in years. So you have to figure out 6 months, M-O-N-T-H-S, is half a year. So when I'm plugging in time in years, I need to plug in 0.5 is my T. So over here, I'm going to say 0.5. All right, and all of this is equal to my A. A is what I'm solving for. I think we've got a good setup. Go ahead and solve it. Number 4, how much interest will you earn in 8 years if you invest $7,500 at 4 1/4% compounded semi-annually? So first off, which equation are you going to be using? Not PERT, because that would be compounding continuously. Not the a, b to the cx, because it's not just a general exponential problem. It should be amount in the account at any time t equals p times 1 plus r over n to the nt. Now, I don't want to know the amount in the account. That's not what the question's asking. The question is asking how much interest are you going to earn. So if you're trying to figure out how much interest you're going to earn, what we're going to have to do is we're going to have to find the amount that's in the account after 8 years. And then, so we're going to find whatever that is. And then I want to know the difference between the amount that's in the account, which was going to be A. Whoa, that got a skinny A. And the amount that I invested, which is the P, the principal, that is the interest earned.
Am I on? All right, we'll get started in a few minutes.
If you can hear that, that's my yoga class that's about to start online. Social distancing, but we're not starting yet, so let's finish this problem. Okay, so the amount in the account, so you need to just go through here now. 8 is your T. $7,500, that's the amount that I'm investing, so that is my P. 4 1/4%, let's see, what's that going to be? That's your R. This is 4.25, and it's 4.25%. You have to make that a decimal. Do not forget to make that a decimal. So it's 0.0425. That's my R. And then compounded semi-annually. Semi-annually is twice per year. So 2 is your N. So just go through, fill it all in. 7,500, 1 plus 0.0425 over 2 raised to the 8 times 2. So here's your equation, and this is again going to give you the total amount in the account. I highly suggest you enter this all at once. Remember, you need to put your exponent in parentheses if you have a calculator that doesn't take you up, like it doesn't put the exponent up in the top. So I think you guys have everything you need to solve this problem. Next question, number 5. In 1910, the population of Math Valley was 15,000. If the population is increasing at an annual rate of 2.4%, what is the population in 1965? Okay, so which equation are you going to use? It's not PERT, I'll tell you that much. It's not the money one because we're not even talking about money. You want to use your general exponential equation. We're just going to say y is equal to a b to the cx. So write your equation. What's your initial amount? 15,000. That's going to be your a. 15,000. Okay, what is your b? The population is increasing at 2.4%. I'll tell you a couple things that are not b. B is not, it's not 2.4. Why not? Well, a couple reasons. 2.4, that's a percentage, and that's not what B is. I'll tell you what else B is not. B is not 0.024. We're getting closer because that's a decimal, but if B was 0.024, the population, it's bad news for the population. It's going from 100% down to 2.4%. That's a major decrease. It's also not 100 minus 2.4. That would be if it was decreasing at 2.4%. What B is, I'll use lowercase this time, B is 100 plus 2.4, 102.4%. So that's what it is as a decimal. As a percentage. So as a decimal, it is 1.024. That's what your B is. So 1.024. How many times is it increasing per year? Well, it just says annual rate, so that means it's increasing once per year. So we're just going to say x up top, and this is equal to y. So here's our equation. Y is, of course, the total population at any year x, and x is technically years after 1910, because that's our starting year. This is year 0. Year 0. So if 1910 is year 0, what is 1965? Well, do the subtraction in your head or on your calculator. This is 55 years. Number 6. A herd of elk increased from 75 in 1998 to 310 in 2005. Find the annual percent of increase for this herd. So this question is a lot like number 8 from your exponential equations last week, where you had to find the annual percent increase of the house. The house value had gone up. Now I know that it's attractive to just like find the difference between 310 and 75 and divide it by how many years that is, but that doesn't actually work. That doesn't work for this because this is increasing exponentially. So it's not like increasing the same amount of dollars every year. It's increasing the same percentage every year. So what you have to do is you have to solve this the same way you did last week, number 8. And so this is, of course, going to be a situation where we're using y equals a b to the cx. And your initial amount is 75. 75 is your initial amount. And then 1998, that's your year 0. Year 0. So 1998 is your starting amount. Now, 310. 310 we are going to use to find the annual percent increase. And then let's just say 2005 is 7 years after 1998. So this is year 7. So what we're going to do is we're going to set up an equation. Again, we don't know what B is. And so since we don't know what B is, we're going to actually solve for B. And it is an annual percent increase, so we know we're increasing once a year. So we know that 75 is A. I do not know what B is. I'm going to put B. 75 times B. Now, I'm going to eventually, I could write an equation with this, but I know one situation. I know that in 7 years, the herd was equal to 310. There was 310 at year 7. So this is just like with the house problem that we did last week. So we're actually saying, so at year 7, this is a specific situation. At year 7, this is what the equation should equal, and that's what you're going to use to solve for the b. So you need to isolate the b now. First, you need to get rid of the 75, because remember we're doing reverse order of operations, so we're going to get rid of multiplication before we get rid of exponents. So divide both sides by 75. I'm lazy. I'm not going to actually do this division. I know this can be reduced, but frankly, I don't really care. I'm just going to leave it just like that. Don't reduce this and get like a decimal that's repeating. That's going to mess you up. Just leave it like that. Okay, now you're trying to get your b alone. So what are you going to do? Opposite of raising something to the 7th power is raising something to the 1/7 power, or taking the 1/7 root. So I'm going to take the 1/7 on each side. That, of course, these two operations cancel each other out. So you end up with 310 over 75 raised to the 1/7 is equal to b. Do that on your calculator, and then your calculator is going to give you a decimal. Make sure you change that into a percentage. A percentage is, of course, moving the decimal 2 places to the right. So there you go for number 6. Number 7, we got a certain species of bird that's in danger of becoming extinct. There were 1,500 birds in 2000, and they are decreasing at an annual rate of 6.5%. If this trend continues, how many birds will be left by 2010? So, number 1, what kind of equation are you going to use? You should be thinking this is going to be a y equals ab to the cx situation. Now, you know that 1,500 birds is your initial amount. So, I'm going to plug that in, 1,500. My b is going to be, let's see, I'm decreasing at an annual rate of 6.5%. So remember what we do for that. You've got to take 100% minus 6.5%. That ends up with 93.5%. And that's a percentage. You got to make it into a decimal. So that's 0.935. So that's your B, 0.935. And then it's raised to the, let's see, how many times is it decreasing per year? Just once, annual rate. That just means 1 time per year. So this is x up here. There's my y, so there's my equation. So first question is, how many birds will be left by the year 2010? Do not plug in a 2010 for x. Don't do that, because year 2000 is year 0. So that would mean that 2010 is year, if you said 10, you are right. You're going to plug that 10 in for the y or x. Which one? Which one? Think about it. Well, the y represents the number of birds, and the x represents years after 2000. So I'm going to let you think about that, and you have everything you need. Part B, how many birds would there have been in 1990? There's a couple ways you can do this. You can kind of reverse engineer an equation, which one person did on their homework for the number 8. That was kind of like this last week. Or you can use the same equation that you used above, same equation that we wrote, 0.935 to the x. But think about, what is year 1990 in reference to 2000? 1990 is 10 years before 2000, which would technically mean you want to plug in a -10. -10 is what you're going to plug in for x, and that should give you the amount of birds in 1990.